mediando aqui a apresentação da professora Lisa Ehrlinger. Ela é da Universidade de Potsdam, lá da Alemanha. Trabalhamos com o mesmo assunto, que é qualidade de dados, e ela gentilmente atendeu um pedido meu há uns meses atrás, de estar fazendo uma apresentação dos trabalhos novos que ela está fazendo com relação à qualidade de dados, né? Então, ela trabalha com essa parte de qualidade de dados, mais voltado para o uso de inteligência artificial, né? Que é o foco aqui da apresentação dela, fora outras coisas relacionadas. Então, eu vou estar passando o vídeo agora. Se alguém quiser, depois do final da apresentação, eu tenho parte do texto que eu consegui recuperar do vídeo, caso alguém queira ficar, né? E aí eu entrego para vocês. Então, deixa eu estar aqui disparando o vídeo.
João, eu acho que está vindo sem som. Ô, João, o áudio tá vindo muito baixo, não sei.
Matheus?
Oi, eu tô aqui.
Se quiser, eu passo o link aqui, e aí você coloca o link lá no chat do YouTube, se for essa solução.
Então, vamos por fim tentar aqui para ver se eu consigo apresentar, resolver o problema. Se não der, a gente faz isso.
Tá bom. Porque me parece aqui, que eu entendi, que ele está esperando um arquivo MP3 para sincronizar com a apresentação.
Não, mas deixa eu tentar fazer a apresentação aqui.
Tá?
Eu só pedi o acesso ao vídeo lá, porque eu preciso. O link do Drive está privado.
Tá. Pronto. Está aberto agora. E você consegue rodar.
Não, aqui eu não consigo não, ainda está privado.
É privado?
Uhum. Eu mandei a solicitação de acesso, deve ter chegado no seu e-mail aí.
Tá.
Aquele link do Drive que você mandou no e-mail.
Sim, mas vê se é o mesmo que eu tenho, que eu
Ah, tá,
acabei
você
de...
mandou agora. Entendi.
Isso.
Ok, um momento.
Dá uma olhada.
Uhum. Aqui eu acho que vai funcionar. Vou desligar meu microfone, tá?
Eu já estou vendo coisa aqui.
So, hi everyone, dear Marcelo, dear students. First, thank you so much for having me in this workshop series for computer science at the University of ABC in Brazil. Due to the time shift and the late time of the seminar over there, we decided to do a recording of my workshop. But if you feel that after this talk, you would love to hear more about data quality assessment, you have any pressing questions, please do not hesitate to reach out to me. I also put my email address here in case you would like to contact me. Or otherwise, I very much hope that you all know that also Marcelo is an expert on data quality and can hopefully answer all your questions. And with this, I would like to first mention, before going into detail, that all the content presented in this workshop is not my single effort by me alone, but I'm part of a bigger group, namely the Information Systems Group at the Hasso-Plattner Institute, led by Professor Felix Naumann. And in total, we have 5 people working on data quality, but not enough. We also have a weekly active collaboration with the external experts, which all form together the so-called METIS project. In other words, Hassan Hamouch from the University of Amsterdam, Divesh Srivastava from the AT&T labs in the US, and Lorena Echeverri from Uruguay. And we all form the METIS project. Why METIS? So in Greek mythology, Metis is an Oceanid. She's the first wife of Zeus, and she embodies wisdom, prudence, and deep thought. And when searching for a name of our of a logo for our project, we realized that we need all these abilities to do research about data quality assessment. But before starting to do a deep dive in what we mean with data quality, I would first like to motivate the topic a little bit. And, you know, many people ask me sometimes, okay, why should I care about data quality? Especially now in the era of large language models, we have so many data, we have huge models. These huge models, they can deal with a lot of messy data. So why that? So maybe if you are aware with the AI community a little bit, there is one guy, Sepp Hochreiter. He held the invited talk, the keynote at the most important AI conference, the NeurIPS conference last year, and he pointed out that we are currently in the third phase of AI, which means that we have done all the basic developments. We have also done scaling up our models, and now we try to bring AI back to practice to companies. And while these companies are more or less focused on AI to be competitive, industrialization, it's not only about scaling, it's very much also about quality. And he points out these models still make so many errors. I mean, I think I'm very sure you have experienced it by yourself, but also Sepp Buchheit, he's not born in Scherding, Austria. There is also one award that ChatGPT says he received and he never did. And also recently with the even more recent model ChatGPT 5, I've seen many people posting on LinkedIn trying to get some prediction, and it's just wrong. Even very simple ones that I'm very sure you could do, like draw or every European elementary school kid is told to draw a map of Europe with getting all the countries right. And as you see here, it does really weird stuff. So it's kind of United Kingdom is wrong, sometimes even also Ireland, like the borders are not always right, and especially the wordings are very messy. And with that, you would say, okay, basically we need to care about data quality, but it's not only a nice to have, it's not only in hygiene a question of do we want it, but it's actually required. So in Europe, there's something like the Artificial Intelligence Act that got into place last year. And so this is a regulative by law. Companies need to adhere to this law. And on page 57, it explicitly states that training, validation, and testing data sets shall be relevant, sufficient, representative, and to the best extent free of errors. So here we already see 4 different so-called dimensions of data quality. I will come to this in a little bit more detail. And even more, it's not really clear what means sufficient and to the best extent possible. So I very much believe that we as researchers, we are called to arms to develop actionable measures that companies can actually apply, they can implement it. Because at some point, some lawyer will ask them, okay, how accurate is your data? And I don't know how many people of you can really say, well, the data I collect is like accurate 58% or so. And indeed, even more poor data quality is not a neglectable aspect. So many studies show the impact poor data quality has on artificial intelligence. So one rather comprehensive survey by my colleagues at the Hasso-Plattner Institute is shown here. I've also cited down there. So they performed over 50,000 experiments that clearly show the impact of poor test and train data over 6 different dimensions. In this case, it just shows that if one score drops when you remove data in order to, in other words, you decrease the completeness of the data. And another study also among manufacturers in 2024 indicates that poor quality documents are used for decision making. So I'm not sure how your experience is with real world data, but if you go working in a company, it's amazing how many Excel sheets and CSV files are floating around. So very little people who use relational database and use normalized data. So last but not least, also when looking at you, I mean, some of you may want to get data scientists in the future. What do you want to do? I very much hope you would like to deal with exciting algorithms, but I'm not so sure if so many people want to actually clean and organizing the data. That sounds rather boring. Anyhow, there are many studies that say, well, this is the task that you actually have to do in real world. I mean, maybe you have experienced it yourself. If you've ever tried to train a simple machine learning model on some data set, usually what you need to do is to do some pre-processing, to do some cleaning, and so on. And with that, I really like to move on. I hope I now got your attention that data equality is important, but I think one thing we haven't talked so much about it, what actually is data quality. So I think we have some vague intuition. We talked about data should be accurate, it should be complete, but the problem is there are so many different perspectives on data quality that at some point I created that meme. So what is data quality actually? And when talking to data scientists, so the people analyzing the data, they usually just think, oh, I have a data set, mostly a CSV file that I would like to analyze. So how do I deal with missing values? How do I impute or fill these gaps? How to remove my outliers? So very specific, concrete data errors. On the other hand, many of you might have already done an elementary course in databases, and there I'm sure you learned about how important it is to normalize your data and how to get your data in second, third normal form, Boyce-Codd normal form. Don't forget about that. It's really important because this is the essence or the fundament of every high quality data, I would say. However, there's also research, and honestly, research has already begun in the 1980s by Richard Wang and his team from the MIT. They come more from the process management community, and they thought, oh, how can we conceptually think about data quality? So they came up with the first definition, namely that data should be fit for a specific purpose. They also came up with a lot of methodologies, how to manage data quality in practice, and they come up with a lot of dimensions. And we will hear of these dimensions a little bit later, just a small spoiler. But to wrap it up, my personal experience, I've done a lot of applied research projects with industry and so on. Usually you need to convince manager, and the real problem is usually data cleaning costs, but nobody wants to care about it. So managers usually ask, what does it actually cost? And that's one of the really important questions also for the future. We need to think, how can we quantify cost of data quality assessment and improvement? And with that, I would like to get a little bit deeper in the state of the art. I've spoiled that a little bit in my third perspective. So what do researchers think about it? And indeed, as said, data quality research is not new. It has been around for decades, and typically it's defined by different dimensions. I've just put a table here. It's a very old table. It's from the 1996. It's from the famous Wang and Strong paper, Richard Wang and Diane Strong. And they said, well, we would like to verify what dimensions of data quality are out there and how often are they used. And even further, these data quality dimensions, they can not only refer to the data values itself, as we would intuitively think so, but also to the quality of the schema. So always keep this in mind for the future. We can also assess the schema of a database. But we want to measure, we want to create actionable measures. That means we want to develop metrics. Metrics are formulas to quantify such a dimension with a numerical value. So we will see some examples later on when I talk about more specific challenges. But just that you have an intuition, these dimensions, what examples are there? So one of the most prominent ones are accuracy. reliability, timeliness, but completeness, of course, data should be complete, it should be current, up to date, it should be consistent, it should be understandable, and so on. So there are many more. Unfortunately, the bad news is that until now, there is no standardized classification nor definition for these data quality dimensions, and also not for the metrics. And this brings me to my challenges, why I think we need more, and also what I want to talk about today. So what are the current pressing challenges? Why is data quality not yet fully automatable, and what can we do about it? And with that brings me to 4 challenges I will talk today. The first is to create a unified framework for data quality assessment. The second one is to develop metrics for these dimensions we talked about. The third one is to manage metadata for data quality assessment, and why do we actually need metadata? And the fourth one is to deal with data evolution. And with that, let's start off with the first challenge, the unified framework. The bad news about dimensions, when you remember slide 7 is, I said there is no standard yet, but it's actually worse because there are multiple competing standards out there. I'm sure you know this XKCD meme. So the situation, there are 14 competing standards. Oh, that's really ridiculous. We need to invent a new one. I think that's exactly what happened with data quality. The most recent one is actually also about data quality in the context of artificial intelligence and machine learning. And so there are standards, but nobody widely uses them. So I think there is no widely adopted standard. That's what I really would like to say. And just as an example, if you remember also back, the most cited dimension was accuracy. So apparently accuracy is the dimension people care most about. It's a key dimension in data quality research. However, there are so many different definitions. So Tom Hegemans, one of my former peers, I had a really long chat with him in Little Rock at the International Conference of Information Quality, and he did this wide study on the different definitions of accuracy. And please have a look at this paper. I just put some example definitions and metrics here, and it's crazy how many of them exist. So in practice, every implementer of a tool asks, okay, how can we implement it? Which one is the right one? Remember also the AI Act. It's really important that we tell companies which one is actually usable, which one is actionable, which one can we automate in order to press a button and really calculate this for a specific data set. So the problem in essence is we need to boil it down to measurable things. To give you an example, to the top bottom right, inaccuracy, so the opposite of accuracy, means we divide all inaccurate values through all total values. So thank you very much for this meaningful metrics, but how do I find out? I mean, okay, I can count all my total values. I think that's fine, but how do I get my inaccurate values? And I personally believe there's much more to it, and we will explore this more and what can we do about it in this workshop. So therefore, a few years ago, I thought, oh, there are so many data quality tools out there. I could have a look, what do they implement, what is actually implementable, what is actionable. And the takeaways, these dimensions are just not very widely used. So as you see here, I had a look at enterprise and open source tools, but really a lot of enterprise tools. So what people use in companies, and we observed if these tools implement an accuracy metric, completeness, a consistency, a timeliness metric, and there are very little. So there's only one tool that actually implements a accuracy metric. I did not find any for a consistency or timeliness metric. So in essence, most of these tools, they focus on supporting users in generating rules, and they do not implement metrics for these dimensions. So with that, I recently have a collaboration with Tassos and Vasilis from the University of Thessaloniki, where we only had a look at open source tools. So in other terms, we wanted to really look in the code. What do they implement in terms of low-level functionalities, for example, specific checks? And we went one step further and said, well, if these dimensions do not exist, can we group these low-level functionalities, so the functionalities already implemented in the tools, to meaningful dimensions? And that brought us to the finding that reality and so the research ideal of having many dimensions, where researchers imagined, oh, we have a data quality tool that calculates a set of, 20 dimensions, and we can assess completeness, accuracy, and so on. And for each of these dimensions, we get one probability as a result. That's not reality. Reality looks different. So what is actually implemented in practice means that we have a TQ tool that provides low-level functionalities, and these can be either profiling tasks. If we go back, just for example, to check, to count the number of rows, to count the number of null values. So these are classic data profiling tasks, but also error detection tasks that where we will receive a probability and sometimes also an explanation about which errors exist in the data. So if we go back, we see, for example, which values fall in a specific range or which values are outside of this range. This is supported by most tools, and this is very helpful. I mean, we can detect specific errors. We will come to that later when we talk about what does it mean to develop actionable data quality metrics. And so since there was no suitable tool in practice at my former university, the Johannes Kepler University in Linz, we made our hands dirty. And together with Bernhard Werth and a lot of bachelor and master students from the Johannes Kepler University in Linz, we developed the tool Qualle, which stands for Data Quality Assessment for Integrated Information Environments. And in Qualle, we implemented in total 4 data quality dimensions on instance level and 6 on schema level. And this was a perfect basis to see how can we actually implement the things or the proposals of metrics from research in practice. However, the takeaway was that these are sometimes not executable. So data quality metrics that have been proposed by research are not always implementable in practice. So they are, as said before, there are different ambiguous definitions, but also often these metrics require perfect reference data that does not exist in practice, that we sometimes have to get to. And with that, with all these considerations about data quality metrics, we've seen that there are common problems across dimensions. So for example, where do we get the reference data from? Where do we get the external data from? Where do the data comes from? So from which source does the data come? For which task do we use the data? And therefore, we recently proposed a vision paper because in the METIS project, because we believe that all these aspects require closer considerations by themselves, which is why we are currently promoting to have a fresh look on data quality assessment. So instead of researching these single dimensions, we speak here of 5 facets where resolving the challenge for one facet hopefully addresses these challenges for several dimensions simultaneously. In other words, we have the data facet that deals with challenges with respect to the data, the metadata, the external data, the reference data. We have the source facet, where we could research how the data generation and collection process was conducted, which errors came from that. The system facet, for the infrastructure that stores, handles, and accesses data. The task, I think, is extremely important because already the definition of data quality, namely the fitness for use, tells us we cannot assess data quality without considering the downstream task. And last but not least, also the human facet, because there are some dimensions, we will see some examples later, that cannot be assessed automatically alone, but we also need to incorporate the human aspect to interpret the results. And with that brings me, so I hope that enlightened you your perspective on data quality a little bit, but this brings me to my second challenge, which I believe, so the first one, this is really high level, to create a joint framework. I believe it's not a short-term challenge, it's a long-term challenge where really a lot of researchers worldwide have to contribute and have to agree on. But the second one, I very much hope so, and I think so, it's much more hands-on. Because while we've talked about this bird's eye perspective before, here we make our hands dirty. We think, okay, we think of developing metrics for measuring and benchmarking. And if you think back to the data quality tools and the low-level functionalities, you remember these low-level functionalities. These are not about high-level data quality dimensions, but these are rather very hands-on detecting data errors. And therefore, I believe that while a lot of previous ancient research on data quality dimensions comes from this high-level perspective, we should now investigate data quality from the opposing, from the low-level perspective. So in other ways, can we detect the errors in our data? So from the poor data quality perspectives. And so what can we do here? We have an example data set. We could count null values. I mean, even that you would think is really easy, but if you do not only consider pure, like null, but also placeholder, even this is a little bit challenging. But I think it's clear what you should do in general. And there are also a lot of work on duplicate detection. We can also measure the distribution. This goes more in the area of data profiling. And we can detect the violation of specific rules. And while some of these errors we can directly map to specific data quality dimensions. So just think of, wow, okay, we count all our null values. Of course, we can calculate the completeness from there, but there are also some more subtle dimensions. For example, believability. So I haven't seen a metric for believability, honestly. If you know one, if you develop one, please reach out to me. I'm very happy to discuss that with you. But I think this is one that we should have a look in the future and which is also definitely relevant. Or reputation. Just think of the AI Act. The AI Act says we need to measure the reliability, the relevance of our data. So unfortunately, it's not really easy because also data errors can have many facets. But this is what my colleague Divya is currently working on. She's trying to get hold on these many different data errors because we believe that coming from this low-level perspective, actually eases us the development of measurable and actionable metrics for data quality dimensions. So wait out for that. Just as an example here, we have different textual data errors. They can be out of vocabulary, but even a typo can be in a vocabulary. So you can have a typo in one word, which is again a valid word. So how do you detect it? How do you measure it? How do you define it? So that's not an easy task, but I think a very rewarding one, because it leads us to automated detection of these data errors. And now we will have a little bit deeper look in specific data quality dimensions. More specifically, how can we use knowledge about data errors to develop such metrics? And the first one I would like to talk about is completeness, or the missing data problem, because I have done a lot in that respect, honestly. So while you would think, okay, well, completeness is actually one of the easiest ones, so one of the most straightforward one. I had a 4 years collaboration with the statistics department of an Austrian steel company through my prior employment. And here we investigated huge amounts of data from the hot rolling mill. So this is the place in the factory where the raw steel is heated and then rolled into coils. So and these coils are then sold, for example, for car manufacturing. And despite having these huge amounts of data, some very specific missing values introduced bias in the result of the statistician. So in this case, we worked directly with the statisticians that analyzed the data, and they said, well, it's a problem. We cannot properly analyze the data. We first need to get hold of, we need to know where are our missing data, and especially what pattern do they have. So there are different patterns of missing data. They can be missing completely at random. As you see here, the yellow parts, which you can safely impute. And then sometimes we have these artificial blocks of missing data, which have some dependencies. So these are usually, in this terminology, missing at random or missing not at random. And with the company, we developed a simulation study. We developed a new algorithm based on crow clustering, where we received 18 patterns by the company. And our approach actually could successfully detect all 18 of the simulated patterns. So it was a real success. And we could also publish it in the SSDBM conference. And now you might think, well, after 4 years, you really solved the missing data problem. However, that's not completely the case. I'm still working a little bit with missing values, but in a completely different context. So before, we investigated real explicit missing values, which means nulls, missing tuples, missing attributes, and so on. But in a recent project collaboration with the Mount Sinai Health System in New York, we have the aim to assess the completeness and the diversity of electronic health records. And we used the findings from the steel industry's basis in terms of explicit missing values, but we moved on to investigate the so-called disguised missing values. And these are so-called placeholders. These contain information that the value is not meant to be the real one. So for example, it can be -99, missing, or like placeholder, like the 1st January of 2000. And just to give you an example of a PCR test results, we had a look at that. And there were different PCR test results that we received from our partners. And on the left-hand side, you see the result value. And on the right-hand side, you see our classifications. Basically, we want to classify all these diverse inputs in, okay, has COVID been detected? Has it not been detected? Or was it a missing value? And using a large language model, this was surprisingly good. So this was actually a success. But we move on. We would like to work more on explainable methods in terms of disguised missing values here. So there's much more work to do. The opposite of completeness is too little data. So apparently, you cannot only have too little data, you can also have too much data. And for this data quality dimension, so-called minimality or non-redundancy, we also developed an explainable, novel, applicable metric, which is based on clustering. So first, basically, you calculate the similarity or the distance between all elements in your data, and then you cluster them. And that's currently also re-evaluated in an ongoing project together with the Austrian Postal Service. Another metric that is really executable and automated, I would just shortly hint you on that. It's about readability. In this case, so it has been a work by before the era of LLMs, we've used WordNet lookups, where we just check, does a word exist in a dictionary? Are there any synonyms or homonyms in the data? And we currently at HBI re-evaluating these metrics with language models. So we received extremely good results to check how readable is the data in my database with that. And so this metric is an example. You can look it up, you can implement it, and you can directly use it to assess the readability dimension. So just an outlook on future challenges. So far, I mainly talked about relational data, tabular data, but I think we also really need to make sure to develop data quality metrics for different data models, for example, graphs or non-structured data. So there is work there. I don't want to go into too much detail, but I would just like to hint you to these works to have a look if you are interested in that, follow up on that later. And last but not least, I think an outlook on what we can do with data quality assessment. So I hope I convinced you that there is still a lot of challenges in the assessment itself, because we can also use language models for the detection, as I've shown before with PCR test. And I personally think we should do so. So in that work, this was a collaboration also with the Austrian Postal Service, where we try to detect and clean errors with large language models. And we use different language models for that. But I think one finding was that the data type and pollution level wasn't so important, but more the type of the error. So in summary, very unexpected and subtle, so very contextual data errors are sometimes extremely well investigatable with language models. Doesn't mean we should let do the language model everything, but use it as input for an explainable method, for example. So one outlook, I will come to that in the end. We could also do AI in the loop, not only human in the loop, but also AI in the loop. Treat AI as a human, not reliable, but sometimes with really good input. And to sum this second challenge up, developing data quality metrics for different data quality dimensions is definitely not easy, but I think it's an extremely important task to create meaningful measures. This is the basis for comparison, for comparing the data, for tracking and improvement the data, and therefore we created a list of things that should be discussed for each dimension, we believe. So we should make a clear definition. We should also develop a metric that doesn't rely on any data we don't have. We need to clearly define input, output, and it should be aggregable over different granularity levels. It should be scalable, customizable, and so on. And with that, let me move on to my third challenge, which is managing metadata. Or in other words, how can we collect, integrate, and store contextual knowledge throughout the data quality assessment process? So this challenge is clearly motivated and raised by collaboration with an Austrian motorbike manufacturer. And they purchased a data catalog. So just to clearly explain that concept, the data catalog is nothing more than a tool that profiles all your data and collects all the metadata. And they said, well, we would like to use all this metadata for data quality assessment, but how can we do it? And therefore, we did kind of one step back, going more into research and investigating, okay, what are the needs of the company on the one hand side, and what are the capabilities of the tools on the other hand. And by the needs, we realized that technical metadata management is extremely important, and that's what these tools can do, namely to automatically profile data sources. However, likewise important for these companies is the manual annotation with domain expert knowledge. So just as an example, you have your data source, you have, I don't know, your product data, and you would like to annotate the different terms or labels of the product with your domain expert knowledge. This should be possible. How is this possible? Usually with data responsibility roles, namely that you assign people to data sources and these people are then responsible for it. I mean, this sounds simple, but in practice, that's often not done. And then it's very unclear who is actually responsible for what. People rely on other people for doing it, and in the end, nobody does it. So I think it's very important to clearly outline that aspect. And therefore, in a follow-up study, together with my JKU colleagues, we found that most data catalog tools, these are the black dots here. So we researched, we investigated a lot of the capabilities or the functionalities of a lot of data catalog tools. And they only have very simple structures like tags or business glossaries that allow domain experts to annotate this business metadata. So this is usually not sufficient in practice because when we talked with our company partner, they, as said, they purchased an enterprise data catalog, which is called Informatica data catalog. And Informatica allows to add tags, so-called data domains, to your data. So in other words, you could say, well, this attribute is a label, this attribute is a description, this attribute is my birth date, and so on. But you cannot connect these labels with each other. So you cannot create a semantic data model that makes means of your data. And for that, we believe that we need semantic technology. In our case, we used RDF, the Resource Description Framework, and the Web Ontology language. We created a semantic data model called Gold Case, which adds a knowledge graph on top of this data catalog. And what was very interesting for me, that these open source standards were actually very nice, connectable with the data domains of the data catalog. And therefore, in summary, I strongly believe that these WV3 standards, namely RDF and OWL, they allow for a very high expressiveness. They are compatible. And also in some studies, I linked them below, we showed that developing ontologies for different domains, for example, for the news domain or for technical security standards, really helps the domain experts in grasp the concepts. So in other words, they can easier get hold of the domain if they see a graph, if they see a data model, and so on. And also to highlight that a little bit, I developed 2 different ontologies for data quality assessment itself. The data quality definition ontology to define the statistics, metrics, and the aggregation of the scores, and also the data source description vocabulary to describe the data sources itself. And I hope that convinced you that metadata management is very important. I know this was a little bit high level. It's very much company driven, this challenge, I would say, but it's one that we definitely have to proceed further. And with that, let me conclude this talk with my 4th and last challenge, namely data evolution. So in practice, we all know data is not static, it continuously changes. On the one hand side, we have time series data and stock market data that changes extremely fast. On the other hand, we've also in huge data warehouses, also customer data, also the data of the Austrian postal services. It changes slower, people move, people change their names, and so on. But also address data is updated. So in essence, in every data we have change. And so far, there are not sufficient methods into data quality assessment that incorporate this change. And therefore, one of the main aspects that we would also like to investigate is the temporal dimension of data quality. But what can this be? Just as an example, look here at this weather data example. We have different weather sensors in different Australian weather stations distributed all over Australia, and we have different sensors. But these sensors are not independently of each other. Sometimes a power outage occurs in a larger regions, which affects multiple sensors. But there could also be a measurement unit update, which leads to sometimes a sudden or abrupt change in your quality. And in one of our recent works, we try to describe these temporal data errors. So think back of the work of Livia Badoria. So she wants to get hold of the data errors themselves. So what data errors exists, for example, missing values, Gaussian noise, and so on. And these are static error types. These are the traditional error types. And I think there's a lot of work in that. There's less work, and I recall Marcelo worked on one of them, to think about the temporal aspect of errors. We call it so-called derived errors. In essence, a static error type combined with some kind of change. And there are different patterns of change. So for example, we could have an abrupt change, but we can also, it can change very slowly, incremental. And it can be a reoccurring change, and so on. And this brings me to new challenges, especially with respect to benchmarking. So when developing new solutions to detect these temporal data errors, we first also need to think of how can we create benchmarks, where can we test if we can actually detect these change patterns, and how can we pollute these temporal data errors. For that, we developed the ice waffle tool, which is the first step. So now we can do the pollution. We cannot yet do the detection. That's our next step. So I very much hope it will come in the future. But also a short outlook. I talked of different data models before, coming back to graphs. The temporal dimension of data quality is also very important in graphs. And here we are currently starting collaboration with Lydia Pincher from Wikimedia, because I hope, how many of you know Wikidata? So this is a general purpose knowledge graph that's created both by humans and machines. And also there exist some policies and standards to uphold the quality, but there exists no continuous monitoring. So in other words, if you change something in Wikidata, you would like to see your quality improving. So as said, we're just starting the project, but the goal is here to first extract the history of changes, to extract basic statistics, and based on these statistics, to calculate and store data quality measures over time, and also to develop a dashboard to visualize everything. And with that, I would like to wrap up and conclude this talk. I talked about 4 challenges, namely, and I would like to wrap up and conclude this talk, just a short outline about things go better with cake. I very much hope you have some cake in the break after this talk, but don't forget the 4 challenges we talked about. I think they're important, but don't think that they are all challenges. So there are much more, there are even more than these, but I think 4 that I interweaved a little bit in this talk, just for recap, where the benchmarking and data synthesis and data pollution is extremely important for data quality assessment methods. Also to have humans in the loop and AI in the loop, because I think both are important for the future. And last but not least, also my main work is on relational data. We should take into account different data models, non-structured data, also JSON files, XML files. You would think, okay, this has been researched some years ago, but there are still so many of these files out there that they need further considerations. And I just also put my email address here again. So in case you like this talk, or if you have any follow-up questions, I'm happy for any questions in the future. Thank you so much. Bye.
João, agradeço muito pela disponibilidade da Lisa de compartilhar esse conteúdo com a gente, para o programa de pós-graduação em computação, também para a gente começar na nossa parceria com a graduação, para poder disponibilizar esses seminários também dentro do contexto da graduação. Então, muito obrigado, viu, João, por ter conseguido esse assunto tão interessante. E vou recomendar a todos aí da audiência que, se tiverem interesse de trabalhar com essa área, não hesitem em procurar o professor João.
É isso aí, Matheus. Obrigado. A professora Lisa, ela é super bacana, super disponível, né? Eu venho tratando com ela já há algum tempo, já fiz alguns trabalhos com ela já, e estamos em conversa para fazer outros. Vamos ver se a coisa acontece, né?
Ok, eu agradeço muito então, João. Obrigado, eu sei que você tem aula agora, então é isso. Vou encerrar nesse momento, então, a transmissão no YouTube. E agradeço a todo mundo que dedicou a sua atenção aí para essa transmissão dessa palestra de hoje.
Abraço, gente.